We're going to talk about surds and irrational numbers in this video. When we mention the word surd, we think of things like, for example, square root of 2 or cube root of 4. So surds are what we call roots of numbers. Okay, so square root, cube root, fourth root, nth root, they're forms of surds. But in particular, it's a sort of a type of number with sort of the property where the exact decimal value cannot be determined. So if you take the square root of 2, for example, okay, now I'll just put that there. That's actually just an approximation. The decimal actually goes on forever, and there's no pattern to this number, by the way. Okay, so this is what we mean by irrational, in fact. And that sort of gets me on to the next point, that surds are a type of irrational number. Irrational has the word ratio, so if you just look carefully there, has the word ratio there. So irrational means they cannot be expressed as the ratio of two integer values, okay, a and b. So when we say ratio of integer values, we mean expressed in fraction form, a over b. In other words, there is no fraction, or there is no fraction with that involve integers. So that's sort of, we've got to be careful about that one. Has to be integer values. There's no fraction that involves pure integers where if you divide one number by the other, you're going to get exactly the square root of 2. Again, that is just an approximate number, correct to whatever 9 decimal places or 10 decimal places. So an example, and go back to the square root of 2. Again, we cannot find integer values a and b. We're going to prove this in another video. So I think that's one of the proofs that I really want to run with you all, that we're going to prove the point that certain surds, for example, square root of 2, square root of 3, square root of 5, so on and so on, there's no fraction with integer values that would equal exactly square root of 2. Another similar irrational number that we've looked at, and you would have looked at before, would be the number pi, the ratio between the circumference of a circle and its diameter. So if we sort of bring pi up here on the screen, it's 3.141592654, so on and so on. Actually, again, it continues on forever, this number. So again, pi is not a surd because it's not a root of a number. Okay, to be called a surd, it has to have this radical sign there. That's what that little tick symbol is called. But again, it's a form of an irrational number, and you might have learnt now sort of a long time ago that we could approximate pi with a fraction 22 over 7. Okay, so if we divide 22 by 7, you get 3.1428. It's not exactly 3.1415, but 22 over 7 is close enough for many purposes. All right, moving on. Let's have a look at square roots in particular. So the symbol, so this symbol here, okay, is called the radical symbol. Okay, it's an interesting name, I'm sure, but that is what it's called. Okay, and it actually stands for the positive square root of a number. So in actual fact, there's actually an invisible 2 there. Okay, so we don't show this 2. We don't have to. It's like in algebra. You might have, for example, 1x as a solution. You don't have to say 1x, you just say x. When you have the radical sign without the number, that determines what order root it is, whether it's a cube root or a fourth root or whatever. We assume it to be a square root. Okay, so it stands for the positive square root of a number. So for example, square root of 9 is equal to 3. Now, another way to see that visually, what does a square root mean in terms of area? If I was to draw a square root. The root, like the roots of a tree, it's really the length of the base of that shape. So the base of this shape here, okay, assuming its area is 9, the base of that shape would be 3, because 3 times 3, okay, being a square, 3 times 3 will give you 9. Okay, so there is a relationship with square roots and the area of a square that helps you to visualize what's going on here. The next point is that square root of negative numbers are not real numbers. Okay, they are what we call imaginary numbers represented by the pronumeral I. So as an example, square root of negative 2 could be written as square root of 2i. Now, your typical calculator won't know what to do with these. So if I was to put square root of negative 2 in there, drum roll, you get an error. You think, what? Hang on, what's going on here? We don't know how to deal with these square root of negative numbers yet. But you can still do very meaningful and valuable mathematics with that. It's just that at a year 10 level, or at a junior level, or even at an advanced or an extension 1 level, we don't deal with that, which is kind of a bit of a shame, I guess, because they are quite useful and very interesting. However, if you decide you want to do extension 2 in year 12, you will most certainly deal with those. And also, lastly, the square root of 0 is 0. That's fine. When it's a 0 area, well, it's a square with side length 0, which is sort of nothing, right? But it is still a valid result. Just back to my last point here about this, the positive square root. And I've had this, this discussion a few times, where, square root of 9, some people would argue, oh yeah, but it's also negative 3 as well, because negative 3 times negative 3 gives you positive 9. But it's actually the positive square root, because 9 is a positive number. We know that, okay? So therefore, the square root of 9 will be 3. Where it might get a little bit interesting is if we have, for example, I might just scribble it here. If we have the square root, for example, of x squared is equal to, let's say that's equal to 3. Okay. Then the value of x could in fact be plus or minus 3. Okay. And the reason for that is because the value of x is unknown. We don't know what x is. The square and the square root, in fact, cancel each other out, and we end up getting 3 as an answer. But what we do know for certain is that if x is in fact negative 3 or positive 3, negative 3 all squared gives you 9. Square root of 9 gives you 3. If x is negative 3 all squared is also positive 9. So it doesn't matter what x is, whether it's plus or minus 3. So this example here in blue, in fact, x has 2 solutions there. But if it's known that the number is in fact positive, like 9, it is the positive square root.